find the sum of formula. The sum of all odd digit numbers. The sum of all odd digit numbers that can be formed by using n non-zero digits that can be formed n non-zero digits that is 1 is less than or equals to r is less than or equals to n is less than or equals to 9. 1 is less than or equals to r is less than or equals to n is less than or equals to 9. That means that is not included 0. Not included 0. That is not included 0. The sum of all odd digit numbers. The sum of all odd digit numbers that can be found by using n non-zero digits. That means 1 is less than or equals to r is less than or equals to n is less than or equals to 9. That means not included 0. That is what? Not included 0. We want the sum is equals to formula clearly that is equals to n minus 1 p r minus 1 n minus 1 p r minus 1 into sum of all the digits, sum of all the given digits, sum of all the digits into 1, 1, and so on up to r times. So the sum of all r digit numbers, that can be formed by using n non-zero digits. N non-zero digits is nothing but r and n value clearly greater than or equals to, less than or equals to. That means 1 is greater than or equals to r is 1 is less than or equals to r is less than or equals to n is less than or equals to 9. So that means clearly not included 0, remaining total digits that is 1 to 9. So what is the formula is n minus 1 p r minus 1 into sum of all the n digits, clearly n digits into r into 1 into 1 into 1 into 1 into up to how many times means r times. This is the formula. Already we discussed in previous one example, that is clearly the sum of all the 2-digit numbers, that can be formed by example. Already we discussed in previous the sum of all the 2-digit numbers, the sum of all the 2-digit numbers, the sum of all the 2-digit numbers that can be formed by using the digits is equals to using the digits 1, 2, 3 is already we discussed in previous example. We get how much the answer is clearly 130. So observe here by using of the formula how to calculate this here. R is equals to how much 2 and n is equals to clearly number of digits equals to 3. So we want their sum is equals to clearly n minus 1 p r minus 1. N minus 1 p r minus 1 means clearly n value 3 minus 1 p r minus 1 clearly r value 2 minus 1 into sum of all the digits, that means 1 plus 2 plus 3, sum of all the digits into 1 into 1 into 1 into up to r times. 1 into 1 into 1 into how many times? 2 times. R times 2 times. So that is equal to 3 minus 1 clearly 2b, 2 minus 1 1. 2p1 into 3 plus 2 5, 5 plus 1 how much 6 into 11. 2p1 value 2p1 is nothing but 2 factorial by 2 minus 1 factorial, we get 2 only. So 2 into 6 into 11. That is 2, 6, 12, 12 into 11. We get 132 only. So this is the formula to calculate the sum of all the r digit numbers. The sum of all the r digit numbers that can be formed by the using the digits. That can be formed by the using the digits. N, that can be formed using the digits n non-zero digits. N non-zero digits, that means not included 0. Not included 0. The formula is clearly n minus 1 p r minus 1. N minus 1 p r minus 1. The sum of all the digits. The sum of all the digits into 1 into 1 into 1 into 1 into up to r times. Up to r times. This is the This is the formula. N minus 1 p r minus 1. N minus 1 p r minus 1 into sum of all the digits into 1 into 1 into 1 into up to r times. Next one. Yes. In the above formula, if 0 is included means, if 0 is included, that means 0 is the one of the given digits. 0 is the one of the given digits. So how to find the sum of all the digits means, observe here the sum of all the, right, next formula, that is the sum of all the r digit numbers, the sum of all the r digit numbers that can be formed by using the digits n digits, including n different digits, including 0. If one of the digits is 0, how to calculate their sum means, we have a formula that is equals to n minus 1 p r minus 1 into sum of all the digits, the sum of all the digits into 1, 1, 1 and so on up to r times 1, 1, 1 so on up to r times minus n minus 2 p r minus 2, n minus 2 p r minus 2, sum of all the digits, the sum of all the digits into 1 into 1 and so on up to r minus 1. This is the formula. If 0 is included, how to calculate the sum of all the r digit numbers? The sum of all the r digit numbers means we have a formula that is n minus 1 p r minus 1. The sum of all the digits, the sum of all the given n digits into 1 into 1 into 1 into up to r times minus n minus 2 p r minus 2, n minus 2 p r minus 2. The sum of all the digits into 1 into 1 into 1 into 1 into up to r minus 1 times. Let us discuss one example here. Find all the 4 digit numbers. Find all the 4 digit numbers that can be formed by using the digits 1, 0, 1, 2, 3, 4, 5. Find the sum of all the 4 digit numbers that can be formed by using the digits 0, 1, 2, 3, 4, 5 is. We have a formula that is n minus 1 p r minus 1 into sum of all the digits into 1 into 1 into 1 into up to r up to r minus 1 times. Observe here, solutions. Clearly, we want 4-digit numbers. Clearly, r is equal to 4. We have a digits, that is, given digits is 0, 1, 2, 3, 4, 5. That means 1, 2, 3, 4, 5, 6. So clearly, how much n is equal to? N is equal to 6. Therefore, total number of permutations are their sum is equal to, observe here, substitute here, n minus 1, 6 minus 1, p, r minus 1, r value how much? 4 minus 1, 4 minus 1, the sum of all the digits, that is 0 plus 1 plus 2 plus 3 plus 4 plus 5 into 1 into 1 into 1 into up to r times. R times means clearly 4 times, that is minus n minus 2 p r minus 2. N minus 2 means here n minus 6. So 6 minus 2 p r minus 2 clearly 4 minus 2 r value 4 into sum of all the digits 0 plus 1 plus 2 plus 3 plus 4 plus 5 into 1 into 1 into r minus 1 times, that is clearly 4 minus 1 times, we get 3 times. So 6 minus 1 clearly already we know that 5 in 3 into 3, 5 plus 4, 9, 9 plus 1, 10, 10 plus 5, 15. So 15 into 1 into 1 into 1, that is minus 6 minus 2, we get 4p, 4 minus 2, 4p2 into, here also we get 15 into 1 into 1 into 1. Already we know that 5p3 value, 5p3 is equal to 5 factorial by 5 minus 3 factorial, 2 and 2 factorial get cancelled, we get 3, 4, 5, 3, 4, 12, 5 is 60. So 60 into 15 into 1 into 1 into 1 into 1 minus 4p2 is nothing but 4 factorial by 4 minus 2 factorial, 2 factorial and 2 factorial get cancelled, 3, 4, 12 into 15 into 1 into 1 into 1. So, by 15 6 already we know that 15 6 is how much? 90. So 900. So 900 into 1, 2, 3, 4. That is 900. That is 900. 1, 9, 9, 9. So we get that is 9, double 0 minus 12 15s are clearly 12 15s are how much? 180. 12 10s are 120, 12 5 60, 180. 180 into triple 1. So 0 8 1 0 8 1 0 8 1. Clearly 0 8 9 9 1. So 1990. 1990. If you subtract this one, 1 0 8 9 9 1, we get 0 9 10 minus 8 2, 18 minus 9 9. So 18 minus 9 again 9. So 8 minus 1, that is 7. So 9 7, that is equals to 9 7 9 9 2. So the sum is equal to this one. So if 0 is the one of the digit, how to find the sum of all the odd digit numbers that can be found by using the n given distinct digits, n minus 1 p r minus 1 into the sum of all the digits into 1 into 1 into 1 into up to r times minus n minus 2 p r minus 1 r minus 2 into the sum of all the digits into 1 into 1 into 1 into up to r minus 1 times. If 0 is included, this is the next topic, that is in this section we learned about the permutations. In this section we learned about the permutation in which the repetition of things is allowed. That is each of the given n dissimilar things. Each of the given n dissimilar things can be used any number of times. But in the literature, observe here, but in the literature, we come across many words. many words whose spellings, we come across many words whose spellings contains certain repeated letters. Like observe here, mathematics. Observe here M is repeated 2 times, and A is also repeated 2 times, and T is also repeated 2 times, and this is. Observe here. So in the letter, but in this section, the spellings contains the certain repeated letters like mathematics. Again, we take coffee, C-O-F-F-E. Observe here, C-O-F-F-E. Observe here, F is repeated 2 times, E is also repeated 2 times. Association, that is ASSO, association, ASSO, CIA, PION, association, that is association. Observe here, S is repeated 2 times, I is repeated 2 times, Mississippi, MI, SSI, PPI, Mississippi. Observe here, S is repeated 4 times, I is repeated 4 times, P is repeated 2 times. That means it contains repeated letters. Or M set, here also E is repeated 2 times. Or some and many numbers. Observe here some numbers with the repeated digits. Many numbers with the repeated digits. That is 4, 7, 4, 3, 3, 6. Observe here 4 is repeated 2 times and 3 is repeated 2 times. And 3007, here 0 repeated 2 times. 112, 112, here 1 is repeted 2 times. Or 121, here also 1 is repeated 2 times. So in this section, etc. So in this section, we find the number of permutations of such words or numbers. Number of permutations of such words or numbers, that is permutations of similar things. Permutations of similar things. Permutations of similar things. In this previous concept, that is previous video, we discussed permutations of n dissimilar things. Permutations of n dissimilar things, and permutations of n dissimilar things that can be repeated. Repetition is not allowed. How to calculate the number of permutations means we have a formula, that is NPR. If the repetition is allowed means how to calculate the number of the permutations means already we discussed, that is n power r. But here permutations of similar things. That means in this section we have learnt about the permutation which the repetition of things is allowed. That is, each of the given n dissimilar things may be used any number of times. But in the literature, observe here, we come across many words whose spellings contains certain repeated letters. That is mathematics, or coffee, or association, or Mississippi, and or some, that is numbers contains repeated letters, that is 474, 336, and 3007, and 112, and 121. So in this section, how to find the number of permutations? In the previous section, we learned about the number of permutations of n dissimilar things. But here we learned about the number of permutations of similar things. Similar things means repeated things. A is repeated 2 times, M is repeated 2 times, D is repeated 2 times. Here coffee, F is repeated 2 times, E is repeated 2 times. Association, so S is repeated 2 times, I is repeated 2 times. And Mississippi, observe here, I is repeated 4 times, S is repeated times. In this section, how to calculate the number of the permutations. If we have n different things, permutation is not the n different things. The number of the permutations of r things taken at a time, n things taken r at a time is clearly NPR if the repetition is not allowed. If the repetition is allowed, the formula is n power r. But here we have similar things. So how to calculate the number of the permutations means we have a theorem. Let us discuss one. Yes, let us discuss one theorem, that is the number of linear permutations. The number of theorem. The number of linear permutations, the number of linear permutations of n things, the number of linear permutations of n things in which the number of linear permutations of n things in which PR alike, that means PR alike means in which P things are alike. P things are alike means same kind of things. P things are alike means repeated letters, that is P things are repeated, are like, and the rest are the different, and the rest are different is formula is n factorial by p. N factorial by p factorial. N factorial by p factorial. Observe this theorem. The number of the linear permutations of n different things or n things, that is n similar things or n different things. The number of linear permutations of n things. The number of linear permutations of n things. Here p are same kind of things. P things are repeated. That means n things in which p things are alike. P things are alike means p things are same kind of things. That means p things are repeated. Mississippi, 4 S are repeated, 4 I's are repeated. Here also p things are repeated, and the rest are the different. What is the formula to find the number of the permutations? Means n factorial by p factorial. N factorial by p factorial. Observe once again the theorem. The number of the linear permutations of n things. The number of the linear permutations of n things in which p things are alike. P things are alike means p things are repeated. P things are same kind of things. Remaining rest are the different. Is formula is n factorial by p factorial. N factorial by p factorial. Observe here. We have n things. That is, we have n things. Clearly, we have n things. Observe here. Let k be the number of required permutations. Let us assume that k be the number of required permutations. Let us assume that k be the required number of the permutations. Consider of these permutations. This permutations contains PR like things and n minus PR different things. That means n things we have p things are alike and n minus p things are different. N minus p things are dissimilar things. These are n p things are similar things. Here dissimilar things. Total we have n things. Here p things are similar things. P things are alike. P things are similar things. If you remove the things, if you remove the p, we have n minus p dissimilar things. N minus p dissimilar things. The total number of the permutations, let us assume the total number of the permutations is, let us assume that total number of permutations is equal to how much? K. So in this section things are different from the rest of n minus p on alike things. So then can we get the number of the permutations? So number of the permutations here p factorial. Number of the permutations is hereby p factorial. P factorial permutating in these new p, unlike without alternating the position of the old n minus p things. Thus a single permutations gives rise to the p factorial permutations. The single permutation gives rise to the p factorial permutations. Hence the k permutation of given rise to k into k permutation is given rise to k into p factorial. K into p factorial permutations. So since the n things are dissimilar, the number of permutations obtained by taking the things n factorial is merely k times of n factorial. K times of n factorial is equals to k times of p factorial is equals to how much? N factorial. K times of p factorial equals how much? N factorial. We want the value of k, so k is equals to n factorial by p factorial. K is equals to n factorial by p factorial. Observe here the number of linear permutations of n things in which the p things are alike. P things are same, but the rest are the different. How to calculate the number of the permutations is n factorial by p factorial. N factorial by p factorial. Observe here we have n things. P are different things, that is p are alike things means same, that is similar things. N minus p are dissimilar things. N minus p are dissimilar things. Let us assume the total number of the permutations. Total number of the permutations is, let us assume that k. Let us assume that total number of the permutations is equals to how much? K. Total number of permutations is equals to how much? K. So k into here p things is similar means p things are arranged in p factorial means. P things are arranged in p factorial means. So k times of p factorial is equals to k times of p factorial is equals to total things, how many things? N factorial. So k times of p factorial is equals to n factorial. We want the value of k. So k is equals to p n factorial by p factorial. K is equals to n factorial by p factorial. We can extend this result for the case of when we have more than one set of alike things. More than one set of alike things in the given things by applying theorem repeatedly as given in the following like this. If we extend the formula, that is n factorial by p factorial, that is the number of linear permutations or permutations, the number of linear permutations of n things, the number of linear permutations of n things in which p like things of same kind, p like things of same kind, comma q like things of second kind, q like things of second kind, comma r like things of third kind, r like things of third kind, and rest are different, and rest are linear permutations of n things. The number of linear permutations of n things in which p like things are same kind, p like things are same kind, and q like things of second kind, r like things of third kind. Therefore, rest are the different. That is equals to formula. Clearly, that is equals to total n things. So n factorial by p of the first p like things are first kind, so p factorial into q are the q like things of the second kind, so q factorial into r like things of the third kind, that is r factorial. So the number of the permutations, the number of the linear permutations of n things, the number of the linear permutations of n things, p like things of same kind, p like things of same kind, q like things of second kind, r like things of third kind, and the rest are different is clearly n factorial by p factorial into q factorial into r factorial. n factorial by p factorial into q factorial into r factorial. If we extend the formula same as, that is p1 things of same kind, p1 things of same kind, and p2 things of second kind, p2 things of second kind, and p3 things of third kind, and so on. pk things of kth kind, then the number of then the total number of permutations, then the total number of permutations taken all at a time. Clearly, then the total number of permutations was taken all at a time is clear. That is p1 plus, p2 plus, p3 plus, and so on. pk plus pk factorial by, that is p1 factorial into p2 factorial into p3 factorial into, and so on, pk. So the number of the permutations of same kind of things, p things are alike, the number of permutations of n things, if p things are alike, the number of the permutations is clearly n factorial by p factorial. Already we discussed n factorial by p factorial. Say this formula extended up to if three things are alike, that means p like things are same kind, and q like things are second kind, and r like things are third kind. The formula may be n factorial by p factorial into q factorial into r factorial. If we extend the formula up to k things, that is p1 things of same kind, p2 things of second kind, and p3 things of third kind, and so on, pk things of the kth kind, then the total number of permutations of taken all at a time is clearly p1 plus p2 plus p3 plus and so on, plus pk factorial by p1 factorial into p2 factorial into p3 factorial into, and so on, pn pk factorial. Let us discuss one example here. Example clearly. Find the permutations of the letter, that is word, that is Mississippi. Find the permutations of, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Clearly, n is equals to 11. n is equals to 11. Observe here, taken all at a time. We want the number of the permutations of the word, Mississippi. Number of linear permutations. Number of linear permutations of word Mississippi means, observe here, S is 2 times, sorry, M is only 1 time, S is 4 times. 4 times, S is 4 times, and I is also 4 times. I is also 4 times. S is 4 times. I is also 4 times. P is 2 times. P is 2 times. Rest are different. That is the one. M is different. So we want number of permutations. Number of permutations. Number of permutations is equals to n factorial by, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial by, 11 factorial by. Which are repeated? Yes are repeated 4 times. Right here 4 factorial into. Also I are repeated 4 times. So 4 factorial into. Also P also repeated 2 times. Right here 2 factorial. Which are repeated, divide the total number of permutations by, divide the repeated permutations, we get the total permutations. That is equals to. Clearly, 4 factorial get cancelled, we get 5 into 6 into 7 into 8 into 9 into 10 into 11. But 4 factorial means, already we know that 1 into 2 into 3 into 4 into 1 into 2, that is 2. 2 factorial means we get 2 only. So 4 ones, 4 to 2 and 2 get cancelled. 3, 2 is 6 get cancelled. Like next, 5, 7 is 35. 35 tens are 350. 350 into 9 11s 99. 9 11s are 99. So we get 900, 95, 45, 93, 27, 27, 4. How much? That is 31. Clearly again we get 3150. 0, 5, 6, 4, 3. So 3, 4, 6, 5. 3, 4, 6, 5. So 34,650 permutations we get. Observe here, the number of permutations of n things in which P-like things are same kind and Q-like things are second kind and R-like things are different kind, third kind, and rest are different. Then the formula is clearly n factorial by P factorial into Q factorial into R factorial. So the number of permutations of the word Mississippi, the number of permutations of the word Mississippi means here S is repeated 4 times, I is repeated 4 times, and P also repeated 2 times. So number of permutations is equal to total letters we get 11. So 11 factorial by 4 factorial into I repeated 4 times, again 4 factorial into P repeated 2 times. So 2 factorial. We get 34,650 is the number of the permutations. Yes, in previous section we learned about the rank. Already we discussed rank is the place in which the given thing lies in the given order. Rank is the place. Rank is the place in which given thing lies in the given order. Already we discussed in previous chapter, that is, rank is the place in which the given thing lies in the given order. In previous section we find the rank of n different objects. Here we find the rank about same some P things of same kind and Q things of same kind, the rest are different. So how to find the rank? Observe one example here. If the letters of the word and set, if the letters of the word and set are permutated, if the letters of the word and set are permutated in all possible ways, and if the word thus formed in the word thus formed are arranged in the dictionary order, find the rank of the word and set. We want a rank of the word and set. Clearly, M set, E-A-L-C-E-D, here clearly E is repeated 2 times. So in this case, how to find the rank of these These kind of problems means observe your solution. First write in dictionary order, that is given word is EAMCE. Given word is clearly unsaid. First we discuss formal method, after we discuss shortcut also. So write the given word is unsaid. What is the dictionary order? Dictionary order is clearly dictionary or that is equals clearly. First we will get A, after we get C, after we get E. E repeated 2 times, take 2 is ACE. After we get M, after that we get E. So ACEEMT are the dictionary order of the M set. We want rank of the word M set. That means if you permutate the M set in all possible ways, what is the position? Rank means rank is the place in which the given things lies in the given order. Given things lies in the given order. Here E is repeated 2 times. Here E is repeated 2 times. So first of all, write the word given word is clearly unsaid and write the dictionary order, that is ACEEMT. So we want unsaid. First in dictionary order, starting with A. 1, 2, 3, 4, 5, 6. So we have 5 blanks, that is 1, 2, 3, 4, 5. How many ways to fill this 5 blank places? How many ways to fill this 5 blank places? Means clearly, if A is starting with A, remaining 1, 2, 3, 4, 5, nearly 5 factorial by. Here E is repeated 2 times, so divided by the 2 factorials. We don't want A. Next dictionary letter is what is that? C. So in dictionary order, that is we get C words. We don't want also C words also. So how many ways? The number of permutations of C words is clearly remaining 1, 2, 3, 4, 5. That is 5 factorial by. Here E is repeated 2 times. Let us divide by the 2 factorial. That's 6. After C completed, next we get E word. Yes, we want E. We want E. So E after we get EA words. Yes, EA also we want. EA after we get EAC. EAC words we don't want. We want EAM words. In dictionary order we get EAC words. EAC words means remaining 1, 2, 3, 3 factorial, that is EAC complete remaining EMT permutated in 3 factorial ways. EMT here, EMT, no letter is repeated, so clearly 3 factorials. Next, EAC after 1, 2, 3, 4, 5, 6. EAC after EAC after we get EAM letters. First EAC after we get EAE letters. So EAE letters also we don't want. That is clearly 3 factorials. We have 3 gaps. How many ways to fill this 3 gaps? Means 3 factorials. EAE completed means EAE completed means after that we get EAM. After that CET. Yes, we get EA. After that M. E after A completed EAC completed E also completed EAM. Yes, we want EAM. After that in dictionary order we get C. After that E. After that T. So we get EAM, that is C E T clearly one. EAM CEDM. So number of. So therefore rank is equal to 5 factorial by 2 factorial, 5 factorial by 2 factorial, 3 factorial, 3 factorial plus 1. So we get 2 times of 5 factorial by 2 factorial plus 2 times of 3 factorial plus 1. Clearly 5 factorial means 1 2 is 2, 2 3 is 6. 5 factorial is nothing but 1 into 2 into 3 into 4 into 5. So 1 2 is 2, 2 3 is 6, 6 4 is 24. 24 5 is 120. So 5 factorial means 122 into 120 by 2 factorial means clearly 2 only plus 2 factorial and 3 factorial means 2 into 3 factorial is how much? 6 plus 1. So 2 and 2 get cancelled. 120 plus 2, 6 are 1 plus 1 clearly. 120 plus 10, 130, 132 plus 1 clearly 133. 133. What is the rank of the word L set? What is the rank of the word L set is clearly 133. What is the rank of the word L set is clearly how much? 133. Let us discuss short. Yes. How to find the rank by using shortcut means observe here. Example. Take M set also. M set. We want rank of the word M set. We want rank of the word M set. So we use shortcut, that is clearly already discussed in previous, that is general process. How to calculate by using a shortcut means write the letters, that is M set. E A M C E T M set. So given numbers of according to dictionary order, we get first A. After that we get, see this is number 2. After that we get E, 3E, here also E also 3. So after that A, B, C, D, E, F, G, H, I, J, K, L, M. So this is 4, this is 5th position. So right in 3, this is in E. Observe here. How many words, how many letters of smaller than 3 means clearly 1, 2, 1, 2. So right here 2. This is 1, this question is 1. How many letters are smaller than 1 means clearly all are greater than 1. So we get 0. How many of them smaller than 4? Clearly 1 and 2. Right here 2. How many of them smaller than 2 means clearly 0. We get 0. How many of them smaller than 3 means clearly here also 0. How many of them smaller than 5 means clearly 0. After that here repeat here similar things is there. So E is repeated 2 times. So by. So including E, how many letters are repeated? That means E are repeated 2 times. So write here 2 factorial. Including E is repeated 2 times, 2 factorials. Remaining including A, not repeated any times, write 1 factorial. Here also 1 factorial. Not including M, not at all repeated anything. Including C, not at all repeating any letters. So here also 1 factorial. Here also. Next, write 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial into 5 factorial plus 1. Plus. So clearly this is 5 factorial into 2 by 2 factorial plus clearly 0 factorial, 0 by 1, 0 by 1 factorial, not 4 factorial into, right? 4 factorial into 0 by 1 factorial. Again plus 3 factorial into 2 by 1 factorial plus 2 factorial into 0 by 1 factorial plus 1 factorial into 0 by 1 factorial plus 0 factorial into 0 by 1 factorial plus 1. Observe here. 5 factorial already we know that 120. 2 by 2 means clearly 1. Plus 2 by 2 factorial means 2 only. So clearly 0 by anything 0. This total that means 0 plus 3 factorial means 6. 6 2s are we get 12. Plus 0 by anything 0. 0 into 2 factorial clearly 0. Plus 0 by anything 0. 0 into 1 factorial also 0. Here also 0 by anything is 0, plus we get 0 plus 1. So 120 plus 12 plus 1, we get 130. 3 is the rank of the word M set. Rank of the word M set. Next, take another example here, that is banana. Take, what is the rank of the word banana? Banana. What is the rank of the word? Banana means, observe here, B, A, N, A. We want rank of the word banana. Rank of the word banana. Write the numbers by using of alphabetic dictionary order, that is 1. This is also 1. This is also A. After B, so this is position, is second position, that is 2. A, B, C, D, E, F, clearly this is 3 and is repeated 2 times. So, 2, how many of them is smaller than 2 means clearly 1, 2, 3. So, write here 3. How many of them is smaller than 1? So, clearly 0. How many of them smaller than 3? Clearly 2. Write here 2. How many of them smaller than 1 means 0. How many of them smaller than 3 means 1. How many of them smaller than 1 is 0. So, here also, right here, we know that number of permutations is similar things. If we have similar things means n factorial by p factorial. So, including B, how many of them repeated? How many of them repeated means including B, A is repeated 2 times, A is repeated 3 times, so 3 factorial into n is repeated 2 times, so 2 factorial. 3 by 3 factorial into 2 factorial, including A, how many of them repeated means clearly A is repeated 3 times into N is repeated 2 times. That is, including N, how many of them in right side only, how many of them repeated means including N is repeated 2 times, A is also repeated 2 times. Including N is repeated 2 times, A is repeated 2 times, so 2 factorial. Next, including A, how many of them repeated means clearly A is repeated 2 times, so 2 factorial. Including N, how many of them repeated? Nothing is repeated 1 factorial. Including A, how many of them clearly 1. So right here, this is 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, plus 1. Plus 1. So rank is equals to clearly rank is equals to 5 factorial into 5 factorial into 3 by 3 factorial into 2 factorial, 5 factorial into 3 by 3 factorial into 2 factorial, plus 4 factorial into 4 factorial into 0 by 3 factorial into 2 factorial, plus 3 factorial into 2 by 2 factorial into 2 factorial, plus 2 factorial into 0 by 2 factorial, plus 1 factorial into 1 by 1 factorial, plus 0 factorial into 0 by 1 factorial, plus 1. Here this is. So already we know that 3 factorial is 6. So 3 ones are 3 twos are 6. 5 factorial means 120. So 120 by here 3 and 3 get cancelled. We have 2 into 2 factorial means 4. So clearly 4 plus 0 by anything 0. 0 into anything also 0. We get 0. 3 factorial means 6. 2 into 2 get cancelled. 2 get cancelled. We get 6 by 2. 6 by 2 plus 3 factorial means 6. 2 factorial means 2 only. 2 and 2 get cancelled. We get another 2. 0 by anything is 0, 0 and anything is also 0. So this is 0. So 1 factorial is 1. 1 by 1 is nothing but 1 only. 0 factorial is nothing but 0. Total 0, that is 1. So 4 ones, 4 30s. 2 ones, 2 3s. That is, the rank is 30 plus 3. 33, 33 plus 1, 34, 34 plus 1, 35. So what is the rank of the word banana in the dictionary order? What is the rank of the word banana? Is clearly 35. So this is the rank of the repeated, that is similar things. If P things are alike, that means A is repeated 3 times, N is repeated 2 times, rank is calculated like this. This is short.